This one is problem number 1.11. It says find the force carried in each bar of the hinged equilateral triangle when loaded as shown. So if you look at pin A, this is a fixed support with two reaction forces, one in the x direction and one in the y direction. And joint C here is the roller support. This will have only a reaction force in the y direction. Now for each pin, what we need to do is we need to see the member force that is coming on the pin. So for example, there's a bar attached to a pin in this manner. When we separate your bar and the pin, and if you assume that the bar is going under tension, there will be equal and opposite force coming on the pin also. So this one is the bar and this one is pin here, right? So what we can see here is that there is always a force going away from the pin in the direction of the bar if the attached bar is going under tension. Based on this, let's try and analyze all the pins in the system. If you look at the joint A here, the forces are this force RAX, force RAY, and a force coming from these two bars, this coming from member AB and this force coming here from member AC. And since it's a equilateral triangle, this angle right here is 60 degrees. Now similarly, if I look at joint B and joint C, I can draw these forces. On joint B, we have this external force which is 450 newtons. Then there will be this force FAB going again away from the pin, and this right here is going to be FBC, and these angles right here are going to be 30 degrees and 30 degrees. Joint C will have this external force which is 450 newtons, reaction force RAY, and member force going this way which is FBC at an angle of 60 degrees, and a horizontal force again going away from the pin, FAC. Now you can see that in terms of unknowns, we have three reactions here and three member forces. Now our objective is to find out the member forces. So let's try and see if we can find these member forces even without solving for reaction forces. Now to solve for these forces, we are going to again look at the equilibrium conditions, which are summation of forces equals to 0. So now with this, if you look at each one of these pins, you will notice that we can count number of unknowns. This one has two unknowns here, FAB and FBC. This one right here has three unknowns here, FAC, FBC and RAY, and this one right here has four unknowns. Okay, since each joint will give us only two equations, so it looks like we should start with joint B and see if we can solve for these two forces based on those two equations. So if I do X force balance on joint B, what we notice here is that FAB sine 30 degrees will be opposed by FBC sine 30 degrees. And similarly, if we do Y force balance, since all of them are pointing in the same direction, their summation is going to be equals to 0. So from the first equation, what we get here is we get FAB is equals to FBC, and when we substitute this into equation number 2, we can say that 2 times FAB cos 30 degrees is equals to minus 450 newtons. So this tells us that FAB equals to FBC is nothing but 225 divided by cos 30 degrees with a negative sign. So if you solve this, your FAB and FBC comes out as minus 259.8 newtons. Now we need to keep in mind that both FAB and FBC are known to us. So again, when we look at these joints, this is known, this one is not known, this one is known. So if you look at the number of unknowns now, this has 3 unknowns, this has 0 unknowns, and this one has 2 unknowns. So it is better for us to analyze joint C now. So let us look at this joint C, and if you look at the X force balance here, we can clearly say that FBC cos 60 degrees plus FAC, both of them are pointing in the negative x direction, will be balanced by this force, which is 450 newtons in the positive direction. Now FBC is already known to us, which is this value right here. So if I substitute that, minus 259.8 cos 60 degrees plus FAC equals to 450 newtons. And if I solve this, the value of FAC comes as 320.1 newtons. So the answer in this problem is that there are 3 members. So let's try to draw them. This one is A, B, and C. Your FAB and FBC, both of them are on compression. This one is under compression, this is under compression, and the force is 259.8 newtons for this one and this one. The FAC member here is under tension, and which is 320.1 newtons. So that's the final answer for this problem.